So we're looking at our trigonometric formulas, deriving these trigonometric formulas. So the last one that we have here is sum to product. So the sum to product formula. So we just proved product to sum formula in the last lecture. And when we did that, we used the sum and difference of our angles. So, and that's the same thing we're going to do for this sum to product. So if we had cosine of alpha plus beta, we know cosine, the sum of two angles for cosine is cosine, cosine, opposite sine, sine, sine. So this is cosine of alpha, cosine beta, minus sine alpha, sine beta. So let's look at the difference of two angles for cosine. So cosine of alpha minus beta. Here we have cosine alpha, cosine beta, opposite sign, so plus sine alpha, sine beta. So looking at this, summing both of these equations together, we would get a sum of two cosines, cosine of alpha plus beta, plus cosine of alpha minus beta. This is equal to, well, cosine alpha, cosine beta, plus cosine alpha, cosine beta. Those are like terms, same angles, same trigonometric functions. So we can sum those together. And this is 2 cosine alpha, cosine beta. And our sine function, sine alpha, sine beta, minus sine alpha, sine beta, those cancel. We want the sum to product. The problem is here that we have cosine of a sum of angles. We don't want that. We want just one angle in there. And so let's do some manipulation. Let's choose A to equal alpha plus beta. And let's choose B to equal alpha minus beta. Should have probably written it below because we're going to use the fact of summing these together. So let me just write B below. So B is alpha minus beta. So now what we need to do is we need to go back and we need to manipulate this alpha piece here to be in terms of A and B, and this beta piece here also to be in terms of A and B. And so we can do that by looking at the formulas that we just let A and B be, or equations, and let's sum these together. So if I sum these together, my betas are going to cancel. So I would get A plus B is equal to 2 alpha. So I want alpha, so I could subtract, or not subtract, to divide both sides by 2. And I get alpha is equal to A plus B all over 2. So now we want to solve for beta. And we can do that by, instead of adding those two equations that we just did, A equals alpha plus beta, and B equals, let's look at the negative of B. So let's instead, so if I multiply this equation by a negative, this would give me negative alpha. On the other side, I'd have plus beta. And so now when I sum these together, I get A minus B is equal to 2 beta. So beta, if I divide both sides by 2, is equal to A minus B all over 2. So we're going to go back in here and we're going to replace what alpha is into this equation and what beta is into this equation. And then we have our sum to product formula for two cosines. So we have here cosine of A plus cosine of B. This is equal to 2 cosine parentheses A plus B all over 2 and cosine of beta, but beta was A minus B all over 2. So similarly, we would derive the other two. So to find the sum of sum to product for summing two sine formulas, we're going to start out the same way, but instead of using the sum and difference of cosine, we're going to use the sum and difference for sine. So sine of alpha plus beta. Well, summing two angles for sine, we know that is sine cosine, sine of the first, alpha, cosine of the second, beta, same sign in between, so plus sine of the second angle, beta, cosine of the first angle, which is alpha. And so now let's look at sine of alpha minus beta. So this is sine alpha, cosine beta, minus sine alpha, cosine beta. Nope, that's wrong. A minus sine beta, cosine alpha. So summing these two equations, we have sine of alpha plus beta plus sine of alpha minus beta. This is equal to 2 sine alpha cosine beta. And the sine beta cosine alphas cancel out with each other. So we can use what we had just done, letting A equal alpha plus beta, and letting B equal the alpha minus beta. And we saw that doing that, we got alpha was equal to A plus B all over 2. And we saw that beta was A minus B all over 2. So putting it together, we have sine A, sine B. This is equal to 2 sine of alpha, alpha, which is A plus B, all over 2, and cosine of beta, which is A minus B, all over 2. Okay, so we have our next product, sum to product formula, and I guess I'm not awake right now. So this should be sine of A plus sine B. So let me see if there's any questions. Okay, so now let's look at it as the difference. If we had looked at this with a difference instead, and we subtracted these equations, we would get the following. We would get sine of alpha plus beta minus sine of alpha minus beta. This is equal to, summing those together, the sine alpha cosine beta minus sine alpha cosine beta, those cancel with each other. And this is equal to 2, there it goes, sine beta cosine alpha. So replacing A with alpha plus beta. So this is sine of A minus sine of B. This is equal to 2 sine of alpha plus beta, or A plus B all over 2, and cosine of alpha, which is A minus B all over 2. I'm wrong. Sine A minus sine B is 2 sine A minus B, because that was beta. And alpha was A plus B all over 2. Okay, so one more. Instead of adding our cosine of alpha plus beta and cosine of alpha minus beta, we would be subtracting those. So if we subtracted those two equations, we would have cosine of alpha plus beta, which we know is cosine of A, minus cosine of alpha minus beta, the alpha minus beta. I keep on saying alpha minus beta, but it's really A minus, alpha minus beta. That is cosine of B, which is equal to 2, summing these. So the cosine alpha cosine beta minus, summing the negative, cosine alpha cosine beta cancels, and we're left with 2 sine alpha. But alpha was the A plus B over 2. Sine of beta, but beta was the A minus B all over 2. Okay, so there are our 4 formulas that are boxed there for the sum or difference of 2 trigonometric functions and to product. So now let's look at some examples of using these. So looking at the following example in front of us, we have cosine of 5 theta minus cosine of 3 theta. And we want to rewrite this in terms of just sines or cosines and or cosines. And so if we look at this sum, rewriting it as our product, we can use our formula that we have above. And this is 2 sine of A plus B, but our A value here is 5 theta, and our B value here is 3 theta. So A plus B is going to give us 5 theta plus 3 theta, all divided by 2. Sine of A minus B, so that is 5 theta minus 3 theta, all over 2. So just combining the numerators and then simplifying if possible. So 5 theta plus 3 theta is 8 theta. 8 theta divided by 2 gives us 4 theta. And then we have sine of 5 theta minus 3 theta, which is 2 theta. That 2 theta divided by 2 is just theta. And so we just wrote that difference as a product of signs. Okay, so I just realized that when we were doing the last deriving of cosine of A minus cosine of B, I was subtracting this off. So this would have been a minus, this would have been a minus. So this should have been a -2 in front. And we just did a problem that had cosine A minus cosine B. So this should have had a minus in front of the 2. Okay, so now looking at an example where we want to show the identity. So we have cosine theta minus cosine of 5 theta all over sine theta plus sine of 5 theta. This is equal to tangent of 2 theta. So we're trying to show an identity. So recall when we're trying to show an identity, we're only looking at one side of the equation, only working with one side and trying to manipulate it to look like the other side. So usually you look at the more complicated side and work with that one. So we're going to work on the left-hand side, LHS, left-hand side. And so we just learned some formulas for the difference of 2 cosines and the sum of 2 sines. So maybe rewriting those in terms of products. And so cosine of theta minus cosine of 5 theta, that was -2. And then it was sine of the sum of the 2 angles. So theta plus 5 theta is 6 theta all over 2 times sine of the difference of our angles. So the difference of our angles, theta minus 5 theta, that is -4 theta all over 2 divided by, so the sum of 2 sines, let's rewrite that as a product. So the sum of 2 sines is 2 cosine of, actually, sum of 2 sines is 2 sine of alpha plus beta. So if I sum those, theta plus 5 theta, that is 6 theta all over 2. And then cosine of the difference of the 2 angles, which is theta minus 5 theta, which is -4 theta all over 2. So things are going to just start canceling out. I noticed that we have 2's that would cancel out. I have a sine of 6 theta over 2, which is 3 theta, all over sine of 6 theta over 2, which is also sine of 3 theta. And so those 2 cancel. And we can do this because it's strictly multiplication in between. And now I see that in the numerator, I'm left with sine of -2 theta. But sine, if you recall, is an odd function. So that meant that sine of negative theta is the same thing as negative sine theta. We're also going to use the fact that cosine is an even function. So cosine of a negative angle is equal to cosine of that positive angle. So going back up here, we're going to rewrite sine of -2 theta. We need to pull out the negative, but we have the minus already out there. So minus a negative, which is actually a positive. So I don't need those. Sine of 2 theta all over cosine of -2 theta is the same thing as cosine of 2 theta. Sine 2 theta. And sine of an angle over cosine of that same angle is tangent of that angle. So this is tangent of 2 theta. So we got what we wanted. We derived or showed that identity. Okay, so showing another identity, we have cosine of theta plus cosine of 3 theta all over 2 cosine of 2 theta. This is equal to cosine of theta. So let's work on our left-hand side again. And let's rewrite cosine theta plus cosine 3 theta using the sum of 2 cosines. And the sum of 2 cosines, that is 2 summing our angles, theta plus 3 theta, so that's 4 theta, all over 2 cosine of the difference of our angles, so theta minus 3 theta, that's negative 2 theta, all over 2, all over 2 cosine 2 theta. So I notice things are starting to look the same. I have those 2 in front, and that cosine of 4 theta over 2 is the cosine of 2 theta, which I also have in the denominator. So I can cancel those out. And then I have cosine of negative theta, because those 2's cancel out with the angles, and that gives me cosine of theta. Which we wanted to show. So in the next example in front of us, we have an equation and we're trying to find theta between 0 and 2 pi, including 0, but not including 2 pi. We have cosine 2 theta plus cosine 4 theta is equal to 0. Unfortunately, those are not the same angles, so we can't sum those cosines. I noticed that I have a 2 theta, so I could kind of manipulate this and use my double angle maybe. But we were just learning about sum to product, and it would be nice to have this as a product equal to 0, because then we can just set each factor equal to 0. So I think we should go about it that way. I think that would probably be easier. So a sum of 2 cosines is the same thing as the product of cosine. Maybe the 2 in front. So 2 times cosine, summing those angles, which is 6 theta divided by 2. So that's going to give me a 3 theta in here. Times cosine, now finding the difference of those 2 angles and divide by 2. So 2 theta minus 4 theta is negative 2 theta, and negative 2 theta divided by 2 is negative theta equals 0. So we have 2 cosine 3 theta. All times, well, cosine of negative theta is same thing as cosine of theta. And this is equal to 0. So we're setting each piece equal to 0. And so 2 is never going to equal 0. Cosine of 3 theta equal to 0. And we're looking at when is cosine of theta equal to 0. Well, let's look at that second one because that's the easiest one. So cosine of theta equals 0. So that's on the y-axis. So that's when theta is equal to pi halves and 3 pi halves. For the next one, cosine of 3 theta equals 0. This is where we wanted to change this cosine, because our argument was just not theta. So we're going to choose A to equal 3 theta. So cosine A equals 0. This is when A is equal to, same thing as we had before, pi halves. But because our argument wasn't just theta, we have to add this plus 2 pi k here. And then we also have A is equal to 3 pi halves plus 2 pi k. But we wanted theta, not A, so we would rewrite that A is 3 theta. And so if we multiply everything through by 1/3, we can get theta by itself. So we get theta is equal to 1/3 times pi halves is pi 6 plus 2 pi k times 1/3 is 2 pi k over 3. So same idea for the second equation here for A. 3 theta equals 3 pi halves plus 2 pi k. If we multiply both sides by 1/3 to get theta by itself, we get that theta is equal to, well, 1/3 times 3 pi halves, the 3's are going to cancel. And so that just gives us pi halves plus 2 pi k times 1/3 is 2 pi k over 3. And so now we're choosing values for k, plugging them in, and we're just trying to find values for theta between 0 and 2 pi. And so letting k equal 0, well, that would give us theta is pi 6. So right here, I'm going to just kind of add them to what we have for cosine theta equals 0. So we have pi 6. And then if I plug in 0 for 2 pi k over 3, that would give me pi halves. But I already have pi halves listed, so I don't need to list that again. So now let's look at when k is 1. So if I go in here and plug in k equals 1, I'm going to get a common denominator. Okay. So when k equals 1, we would have pi 6 plus 4 pi 6. So pi 6 plus 4 pi 6, that is a 5 pi 6. 5 pi 6 is in between 0 and 2 pi, so we're going to write that there. So getting a common denominator for the other one and plugging in 1. So we have 3 pi 6 plus 4 pi 6. 3 pi 6 plus 4 pi 6 is 7 pi 6, which is still between 0 and 2 pi. So now let's look at when k is equal to 2. Okay, so we have a multiplying 4 pi times 2, so that's 8 pi 6 plus 1 pi 6 is 9 pi 6. But that reduces, right? Both of those have 3 in common to 3 pi halves, which we already have written down, so we don't need to write it again. And if we plug in 2 into here, well, we have 4 pi k times 2. So that is 8 pi k 6. The k we already plugged into. So that's 8 pi 6 plus 3 pi 6. 8 pi 6 plus 3 pi 6 is 11 pi 6. Which is still between 0 and 2 pi. Any value of k that we plug in that is bigger than that is going to give us over 2 pi. And so we found our solutions to our equation cosine 2 theta plus cosine 4 theta equals 0. So looking at another example of proving an identity, this time we have sine alpha plus sine beta all over cosine alpha plus cosine beta. We're trying to show that that is equal to tangent of alpha plus beta all over 2. So looking at this, I notice I have a sum of 2 trig functions on the numerator and denominator. So let's work with the left-hand side and rewrite those sums to products. So sine alpha plus sine beta, this is 2 sine alpha plus beta all over 2. And then cosine of alpha minus beta all over 2. And now looking at the sum of cosine, which is 2 cosine of summing our angles, so alpha plus beta, and dividing by 2, and cosine of alpha minus beta. Divided by 2. So things start to fall out again nicely. 2's cancel. I notice we have a cosine of alpha minus beta over 2, both in the numerator and denominator. So these are going to cancel. And so we're left with this sine of alpha plus beta over 2 all over cosine of alpha plus beta all over 2. Well, we know sine of an angle theta over cosine of some angle theta, that's equal tangent of that theta. We have the same angle for sine and cosine, so we can just rewrite this in terms of tangent. And that's what we wanted, was tangent of alpha plus beta all over 2.